Hello, and welcome to a presentation over the structural design process of a speculative office building called One Place. My name is Nathaniel Morris, and I was the lead structural design engineer during this project's lifetime here at NCM Structural Thrills. Now, usually here at NCM, we tend to work more with thrilling and entertaining structures such as roller coasters. But this time, we decided to broaden our experiences as structural engineers by designing a structural system for a 5-story building as requested by our client. We were grateful to be given this opportunity, and we gave it our all to provide a worthy design. Now, let me give you a brief rundown on the project at hand. On screen right now, as shown, is a typical layout of the building itself. As requested by our client, we were to design the structural system of the One Place building, a 5-story, 57,000 square foot speculative office located in Tulsa, Oklahoma. This building is circled in red on screen. The detailed drawings were also provided by our client as too. The One Place will be located across the BOK Center at the corner of Denver Avenue and 2nd Street in downtown Tulsa. Now, in this presentation, there will be 3 parts to dive into. Each one is progressive from the last. And we start off with structural loading analysis. Then we dive into the 2 alternatives that we came up with for gravity and lateral systems. Then finally, we chose one of those systems and put one of them into a detailed structural system design. Here's a list of building codes, manual, and textbooks used in aid of the design process. We had to pull out the relevant material from our undergrad days to freshen up on concepts and processes of structural analysis and design to conquer the challenges that awaited us. Without further ado, let's start talking about the design process, shall we? First part, structural loading analysis. In order to get started with design, we need to perform a structural loading analysis to understand the minimum loadings our building must resist. This will give us a better understanding on the preliminary design to get us started and what types of structural systems to use. Performance of the structural loading analysis was done per ASCE 710 standards. Shown on screen are the tables of the respective load categories we had to keep in mind, and sequentially found the highest loading from the factored load scenarios. And following these processes of these standards, using ASCE 710, and also using the detailed floor layouts provided to us by our client, we concluded that each floor for the gravity system will need to withstand 211 pounds per square foot, and a lateral system to withstand at least 13.9 pounds per square foot. Out of the way, let's get to part 2. Both alternatives includes a gravity and lateral system. Symmetry and architectural considerations were taken into account throughout the deciding process in order to keep the design simple. Column locations for both systems will be relatively the same, and each bay predominantly consists of equal spans of 24 foot in both directions. There will be a beam or multiple beams in the middle of each bay to help support floor loadings and minimize deflection. Firstly, let's talk about the first alternative, a complete steel structure with a 4-inch concrete floor slab. For the gravity system, steel I-beam sections will be the predominant members for both the beams and girders and columns, with the beam connections predominantly consist of bolted double angles. Now for the lateral system, two designs were brought to our attention. One lateral system consists of an HSS lateral bracing system. These would be placed in various spots around the outside of the building. Or we also have an HSS steel knee brace system that would, that would be placed at the corners of the column and beam intersection, connecting the upper beam to the column. This system would allow us to keep the lateral bracing internally with minimal disruption in architectural design. It ultimately would make the system a frame system. So here's the gravity system. This is a typical bay layout, and it'll be connected with beams between each columns and a beam between each bay. And then we have the first lateral system. As a typical cross brace layout, on the left side you can see it's the short side of the building. It's around 72 feet. And then the long side of the building, which is 165 feet. The second lateral system we chose for this alternative was the knee brace. And this is a typical knee brace layout that we would use. And on the right you can see how the knee braces would be oriented. The second structural system alternative consists of a reinforced concrete structure. Each floor will have continuous reinforced concrete beams running along this long span of the building, with beams connecting to the continuous beam on the short side, and a couple beams in between each bay to help support the two-way slab flooring. This would help with the flexion and just the loading in general. Now for the lateral system, we came up with the reinforced concrete shear walls. These will be placed in both directions to withstand the lateral loads being applied to the building. Taking into consideration of the architectural layout, we decided to place the shear walls where stairwells will be placed to minimize the disruption of the outside glass wall. This is a typical bay layout of the reinforced concrete system, and this will be our gravity system. Next, we have the locations on where the shear walls will be placed for our lateral system. These are placed where, like I said before, where stairwells will be predominantly at, and they will reach out to at least the third, fourth story of the building. Let's do a comparison between the two. For the steel frame, we have some pros on there. One big one for us was the design flexibility and also the future adaptability. Cons are listed there as well, which include buckling and the high expansion with changing temperature. It's a big concern whenever it comes to steel frames. And then on the right, we have the reinforced concrete frame. Pros to that is its strength and fire resistance and durability. Fire resistance is big pro compared to the steel frame because heat really does make the make steel material weaker. And the cons with the reinforced concrete frame is that there's not much design flexibility behind it. And then the cons are kind of like the pros for the steel frame, as the future adaptability is not there too much for the reinforced concrete. Now here at NCM, we decided to play to our strengths this time and chose to make the alternative on building with steel. This overall made it easier for us to provide the most accurate results and design since we were playing at home court. Design flexibility and future adaptability were major qualities we looked for when deciding which alternative to choose. Also, the lateral system that we decided to go with was the knee brace. With the minimum loading determined and selected alternative structural system, with the minimum loading determined and selected alternative structural system, it's time to dig into the detailed structural system of our chosen alternative. When it came to the design process, we determined a way to simplify the design process would be a single floor with the most loading on beams and columns were used for each respective floor. For the respective the determination of the first floor's column size will be used throughout the entire building. This will ensure that all loadings on each column can be met as well. Same process goes for the beams on each floor. We can see a typical bay layout as shown on screen, and then also the quantity and tonnage. Now, here are some of a brief look at the connections that we came up with. We have beam to girder. Um, we also have the limit states located on each side. So we have beam to girder, girder to column, column splice, and then also the foundation. The lateral bracing system is just as described earlier, with the knee brace connecting to the bottom flange of the girder and then into the flange of the column. The, the pictures on screen had helped orientate to help give a better perspective on how they will be laid out in the system itself. This connection you and here's a quick look at the connection itself with the limit states to the right. And using AutoCAD, we have a full typical bay with connections and beams, and it brings it all together. In these following slides, you will see the typical beam schedule and also column schedule. Overall, we went through three parts of our design process. Determined the minimum loading required for the building to withstand. Came up with two alternative structural systems to choose from, and ultimately went with the steel structural system. And then we used the minimum loading and chosen alternative to design our structural system. We would like to thank Dr. Voles. We would like to thank our client for giving us the opportunity to test our knowledge as structural engineers here at NCM, Structural Thrills, as we discovered the strengths and weaknesses that we have in designing a building, then a thrilling roller coaster. Thank you. Are there any questions that I can answer?